Hey, how's it going, everyone? So my name is Jason, and I just wanted to go through a quick application here that I really like, and I just wanted to go through how to use it and some of the different features it has. This is a debugger that you can use for Windows. It's called RemedyBG, used for 64-bit Windows. It's basically an alternative to something like Visual Studio, which I know is very popular and everyone uses. In my opinion, the more that we try and get away from Microsoft tools, the better. So I greatly appreciate works like this, and I want to try and promote them. And one way to do that, I think, is just to show you how to use it so that there's not much confusion whenever you download it, if you do download it and decide to use the program. Now, this is actually created by a single developer, and he's done a pretty good job with it. The site that you can download this debugger at is called, you can see right here, we have remedybg.itch.io/remedybg. So that will bring you to this page here. You can see here it's $30, which in my opinion is nothing. It should be, you should have no problem purchasing it for this price, given what the product you're given, which is a very good debugger that's been pretty stable over the past year or so with Windows. Now, the latest version is the 3.9.4. I think I have this installed, but I'm going to go through here and actually just show you how to download it and install it. Basically, once you purchase it, you will have an option to go to the download page, and you can see here some past versions here that you can download. I'm just going to go ahead and download the latest, which is 3.9.4, and we click download. Boom, it's in my downloads folder, and here it is. Now, one of the beautiful things about it is this is it. This is all that's involved in RemedyBG. So all you have to do to install this is to just place this exe wherever you want it. So wherever you want this application to live. So on my system, I actually have it within my C drive. So in order to show you that real quick, let me open up where I have it installed. I have it installed right here. Like I said, I already had the latest version installed, but say I didn't, say this wasn't here. I have these just for reference in case something goes wrong with the new version. Maybe there's a slight bug that's bothering me, whatever. I have these previous versions that I can just go back and grab if I need to. So that's not something you have to do. That's just something I do. That's why you see these different version numbers. But basically, so all you got to do is just copy and paste in here. That's it. It's installed. So you can see this is already a way better process than something like Visual Studio, where you have to download an installer app and then you have to wait for it to install and all these different components and blah, 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 blah. This is really nice, really simple. And you can see I can just click it, and Microsoft being annoying, and it's open and we're good to go. What I want to do now is actually go through and show you how to use this application. So in order to do that, I have a project already set up. I have it here. So you can see I just have a simple project. We have a C file, which just holds our main function. I have a build file, and then we have this is for 10x, the 10x editor that I've been using, and I really like it. So we'll open up our project here with this editor file, and you can see we have our 3 files here, and we have our main.c file. This just has some functions, or I'm sorry, some structures and another helper macros and things like that. Just to go, it's going to help me whenever I show you some of the features that we're going to do within Remedy to show them off. So these are just some helper things for us. You can see I have a build file that's going to go ahead and build this program, just a simple build file here. We'll go over a little bit about it more in a moment. All right, so I can go ahead and build it, and the application will now be within our bin folder. Okay, so what we want to do is we're going to get the Remedy set up so that we're able to step into our exe and debug. So the first thing we want to do here is open up Remedy. I'm going to go to the command line, and I have Remedy already set up as in my path environment variable. So all I have to do is type remedybg.exe and it will open. So we have our application here. And the next thing we're going to do, so we have a session the session tab here. And this is what, if you're familiar with debuggers at all, you'll understand some of this stuff. So we set the command, which is basically the path to the executable. So this is just telling the debugger what we want to run and have debug. So we could click on the three dots here, click on the bin folder, and select our main application. The working directory won't really matter for us today. I'm not doing anything that's going to involve the working directory. We'll just put a dot there. So once I do those two things, I can then go to the source file and open the file that we want to debug. So we're going to open our main file. And we can set a breakpoint here, and then I'll just hit F5, and you can see that we have now stepped into the program. Now the next thing we'll do is we'll just save a session here. So we'll just do a save as. This is basically just a file that Remedy will use to open back up, and it'll have all your settings that you had previously before you closed Remedy. So if we had any breakpoints set or watch window items in there, all that would be saved within this file. So we're just going to create a file here to be used later. We'll just call it debug, and it'll be debug.rdbg, and we'll save that. So now that is our Remedy file that we'll be using. So we can see here we have that saved. So basically now if I were to close Remedy, now you can see that if we just go back to our command line, and then if I just type Remedy, and if I can pass it an argument, so I can just pass that file as an argument to the exe on the command line, and I could just hit enter, and that'll open up that session file that we just saved. So now this will have our session that was set up before as it was, and then we can just, again, we can set a breakpoint and jump into it. Now we can also go in here, we don't have to have an absolute path for the command once we save a session file. So I can just put, instead of this, I can just say, dot meaning look in the current directory, then find the bin folder, then find our main.exe. So we don't have to have an absolute path in there. I can save, and you can see if I hit F5, we still are able to run. So, that's useful in case you're moving to different machines and you just want things to work. You can just make these paths relative as well. The next thing you'll see here, actually, so we'll remove this breakpoint. And the next thing we have is the normal entry point or entry point function. The normal entry point, if we just hover over here, basically what this is referring to is if I didn't have a breakpoint already set here to start on, like I just did, I could just hit F10, and Remedy is going to find the main function and then just stop right before entering the main. So you can see I have the win main function here, and then it just broke right on that win main function. So it does that because we have the normal entry point set, and you can see that the entry point functions include win main, win main CRT startup, that kind of thing, that Remedy will automatically look for when we hit F10 and want to just start at the beginning of our program. Now you can also select entry point function. So it's slightly different. I can show an example of that. If we select that and then I again hit F10, you'll notice that it breaks in the disassembly window. Now I believe this is because, so with C, you have the C runtime, which basically adds in some code that is going to run before the win main function is called. So in C, I believe it might be the win main CRT startup is the name of the function. I forget exactly offhand, but basically the C library is being stepped into and called first. That is actually the entry point of our program. So the C library will be stepped into because, again, we selected entry point. So it's the actual entry point of this application. I think in the description for Remedy, it just describes it as whatever the entry point is listed in our exe file within the header of the exe file. And again, since the C runtime inserts its own main to be called before our win main, that is going to break into that. So I believe that's what's happening here. So it's breaking into win main. And if we step through, it's doing some things here to set up the C environment. And then eventually we would step through, and we would get to our breakpoint here inside the actual main function. So that's what it's doing there, and that's what those options mean here within the session. The next thing here are the environment variables that you can set. I'm not really going to go into too much detail here. There's basically some things you can set in here. For example, I'm going to pull up the Remedy help file. let's see if I can find it. So you can just see the description here. It's going to set variables used by the process. So one thing you can set is the no debug heap. So in general, when Windows operating systems will enable what's called the debug heap by default, and this is basically just a separate heap little memory area that has some extra debugging capabilities in it. I think it's provided by the C runtime library, if I'm not mistaken. But it can actually make your program run slower just because there's that extra debug information in there to help you debug your issues. So Remedy just disables it by default, but you can enable it if you want to. So you can set it to 0, and you can set that in the environment variable here if you want to. So it's stuff like that. Like I said, I'm not going to go too much into it. I don't use it much. All right, so that's basically just what I want to talk about with this here. There's really not much going on with it. But now we'll kind of get into some of the meatier stuff here. So we can see that if I run my program, actually, before we do, let's check out, there's one other thing, and again, the help file mentions this. We're just so everyone's aware, we can access the help file if we go to help, and then we can click it here, or we can just press F1, and that brings up the Remedy help file. Now, this is just going to describe basically everything you can do with Remedy, and it kind of lists everything here. So I'm basically just going to go through and show you everything. Well, most of the stuff, there's some things that I just don't use very much. I don't know if it's as important to go over. Maybe it is down the line. I'm just going to go over some of the more basic things, some of the things I think that are going to be more immediately helpful as I go through this file. But one of the initial things you can see here is it talks about your build file and the kind of options you want to make sure you have, and options you want to make sure are disabled. So if we look at my build file currently within this project, I'm building first with the Microsoft compiler, so that's the CL here. So when I run this batch file, it's calling the Microsoft compiler and then passing in the compiler arguments. Now, the compiler flags you want to make sure you're using. Is it here? All right, so if we look within our bin directory, we can see our main.exe, we can see our PDB file. That was created because I had this argument here. I think I can also put Z7, and that will also be in there. So if I were actually to just remove dir bin, so basically that is deleted now, and I rebuild, and we check our bin directory, that file's still there, right? So there are options where this can actually just be embedded directly in the exe. And that's why Remedy says you got to make sure that you have this specified so that the PDB file gets its own separate file that is not embedded directly in the exe, because that's what Remedy uses to read the debugging information. So that's one of the important things you want to make sure you have in there. You also want to make sure that you don't have, as part of your compiler flags, the JMC option. This, again, is mentioned here in the Remedy file. As far as the JMC, I forget exactly what it is. Let's see, when it's enabled, it inserts calls to a helper function in function pro. So it basically inserts some information that screws Remedy up a bit. So you just want to make sure that you do not have this option enabled. So we just, we'll take it out of there and we should be good to go. So you should make sure you do not have that option either. And then also you have your linker flags. You also just want to have this option here, debug full. I'm not sure if this is the default. I think the default with Microsoft, and I believe Remedy mentions this, we'll see it here. It's called fast link. Yeah, so so the compiler, the Microsoft compiler will default to debug fast link, and this needs to be changed to debug full. So again, this just means Remedy, with how it's built right now, just can't handle the debug fast link for whatever reason. So we just need to make sure we're passing the debug full argument when we're building our project. So as long as you have those things specified in your build file, you should be able to step into and run your program within Remedy. All right, so one of the first things to realize when using Remedy is so we'll just step into the program here. The watch window, you can basically put any sort of expressions that you would put in any normal C program. I think it mentions C99 in the help file as far as valid expressions that you can use. I'm not sure if you can use anything that you could use within a C program as far as what you can put in here, but a lot of things you can just do in this watch window. So for example, we have this, let me create another variable in my file here. So we'll just say, we have a float and we have a variable that holds the float, and there's the float. Compile, go to it. All right, so we have a variable and you can see the value, right? That's the value we set it to. There's some extra garbage numbers because we didn't specify them here. But let's say that for whatever reason, we don't want to view it as a float anymore. We want to view it as an int. So in order to do that, just like you would in a regular C program, you would just create a cast, right? So here we'll just create a cast int var, and you can see we get 3. So that's what I mean. And that's what Remedy means when it says you can do a lot of the expressions that you would be able to do within a valid C99 program. And then there are some special syntax things that you can do that is RemedyBG specific as well, that you can modify what you're looking at. And I'll go ahead and I'll show you through some of that stuff here in a bit. But I just wanted to mention that, so you know, you can do some useful things with that with your variables here in your watch window. You can also specify the numeric literals slightly differently if you want to in here. So if we have, let's actually step through. Okay, so we have an array right now, right? And we have that first one that's set to 1. Let's say for whatever reason, I want to multiply that by some value. Again, I could just do, say this, and it'll give me 10 since it was a 1. But I could also, let's say I wanted to multiply it by a bigger number. There you go. What is that? That's 1,000,000, right? One way to be able to tell easier that that is 1,000,000 that you're putting, you can do this in Remedy. Right, so you can have these little underscores. It just makes it slightly easier to view exactly what kind of numbers you are using when you're doing these kind of multiplications and things in the expressions with inside the watch window. So Remedy allows that, and they have a couple different ways that you can do that. So you can do it that way. I believe you can also do this. So if you do the backtick, that will also evaluate to 1,000,000, right? So that separates those zeros there. You can also do, you can use that within a hexadecimal. So you could say, you know, FF, or whatever, right? So you can see we have these underscores listed and we're just multiplying it. This is going to be some huge number, right? This is just to show that you can also use these underscores within a hexadecimal value that you're using in the expression window. So Remedy allows all that kind of stuff within that. That's good to know going forward, so you can see if I do some certain things within this watch window, it's just because that's what Remedy lets you do. Another quick note here is Remedy allows you to specify the registers and see the register values as you go. You can just actually just talk about them here. So RAX is a register within the x64 assembly instructions, right? So you have the RAX register on these systems, and Remedy will just let you view the contents of that register. So if I go ahead and hit start, you can see the value that's currently in there gets changed as we move through the program, and that's because that register is what's getting modified when you're actually running the program. So Remedy just gives you a quick way to view that register. I don't use these as much currently in my current day-to-day, but you can imagine situations where you do want to view these in a simple and easy way, and you can just list all the registers here and view their contents. All right, so the next thing we're going to look at is the relative scopes. So what I'm going to do actually is we're going to create a function now within our normal program. Actually, we already have one here, right? So I have an add function. So if we just say add func 3, 4, right? And then let's say outside here we had some random variable for something else. Just say it, right? And we'll go compile that. If we go back to remedy. All right, so once I step into this function, remedy by default, so in the watch window, if we put X, it'll show us the value of X because it's within that scope, right? We are currently in the add function scope. So within the scope is the variables that are going to be viewable. Now, what I was going to show you initially was we have the X value that we can view. If I wanted to view the var variable, right, that's outside the scope of this current function, you can see it says it's not found. But Remedy has a way to view it if you want while within another scope. You can do, it's going to be the bracket, closing bracket, right? And you're just saying one. You're saying look one level up to find this variable and display that value. So if I hit enter, you can see it actually will display that now. So it's just looking one scope up from add function, and then it finds the variable, and then it puts the value. So this is pretty useful. You can even do something where you don't have to specify the number. You can just put a star, which is just telling Remedy no matter how deep in the call stack you are. So if you called this function, you know, 1,000,000 times, or if you had a bunch of functions that you're calling one right after another, and you're way down deep in the call stack, and you have this variable that you still want to keep an eye on, you would just put the star here, and basically Remedy just moves up the stack until it can find that variable and resolve it, and it'll display that value here. So that can be pretty useful for some things when you want to see the state of a variable maybe outside the current scope and just see how the values are changing. One other thing to note here is you can also lock the scope of that variable when you're jumping into other functions. So say I were to start here and we have that variable and we can see the value. You see this little lock symbol here. So if we go ahead and select that and then we step into the function, you can see that that actually keeps its value. So even though we're in a different scope, I haven't specified anything here on the watch line to say to, you know, look up and find this variable. It's already been locked. So now you can see that value as you step through. So that's just another way to kind of do that same thing. Just to show you, if I don't have it locked, we have the variable, I step in, it goes away. Okay. All right, so now we'll move on to format specifiers. Now these are things that you can use within Remedy to kind of display different values here that you want to maybe view your variable as. So let me give you an example. We have our variable, okay, right? It's going to be 3223. We have a way in Remedy to say, I want to view this as a binary number. So you would just put a comma and then B. So it's comma and then whatever the format specifier is, hit enter. And you can see now it's going to give us the actual binary value of 3223. So you can see right here, here are the 4 bytes that are going to compromise, or I'm sorry, that are going to make up this int variable. And then we can see the values filled in here. Now we can also view it in hexadecimal with an X. So that'll also give us the value in hexadecimal. It just removes all the unnecessary zeros and just gives us what the actual value is. So again, this is representing the 3223. Now by default, Remedy lists things as the decimal value so that, you know, if you want to specify it explicitly, you would put the D here. And then that's how you can see the decimal value. Now you can also do something like a capital X to have capital, hexadecimal, and things like that. There's one other one that's more Windows specific I won't worry about. One other thing you can do with the format specifiers is you can specify a count with them. So if I go back to our program here and we're just going to have, say, a array of 10 items and we'll just specify the first couple, right, whatever. And we'll build that. All right. So if we go back to our program, come through, we have an array. Now let's get rid of this. We'll write it again, array, right? right, so you can see here with this array variable, we have the first couple numbers that are displayed, and then it's just a bunch of zeros. And if you click the arrow, you can see, the entire array, all the values that are within that array. So obviously we only specified the first 3, so you can see the first 3 here. It knows the length that the array is 10, so it's just going to give us the first 10, first values, 10 values of this memory address, which, an array is just a memory address. If we close that up, so what I was saying earlier is we can use those specifiers that we used before, just like we did with the variable. So I can put an X here, and it's going to display all those values in hexadecimal. And we can do the same with binary if we wanted to, right? Now you can also specify a count. So let's say we only wanted to show, let's say this array was 1,000 elements long. We only wanted to see the first 10. In this case, let's say we only want to see the first 4. So we would just put 4, and then now it'll only display that first 4 elements of that array. You can combine this with the specifiers. So the way you do that is specifier first, followed by the count. So we want to view these in hexadecimal and only view 4 of them. And then there we go. We can view the hexadecimal values of those 4 variables within the array, right? And again, you can use any format specifier you could before. Okay. Right, so the next thing, and this one's actually pretty cool. This is actually just recently added in Remedy, and it has to do with linked lists. All right, so in order to show you that linked list thing, I'm just going to create one real quick. So we're just going to create a linked list. So with linked list, you have a node, right? We have a node. And we have the value. And then we have a list, which holds the head or the first node of the list. And we have to do this because it's C, right? Okay, and then we're going to allocate some nodes. So I actually have some code over here that I'm just going to copy and paste. And here, okay. I just had to call it something differently in the other thing. Okay. All right, so all we're doing, right, we're just allocating some nodes using malloc, and then we're putting that into the list. And the way we do that is just by pushing with the macros. That's going to push it onto the head of the list 1, and then we'll have our linked list, right? So we're just going to compile that, and we're going to go here, and we're going to break on that list. All right, so if we were to view this in the debugger, we have our head, right? We have our next value. So as we go on, all right, so we have node 1 is 23. So what we expect actually with this stack push is it's going to push things onto the front of the stack, and then the rest of the nodes are going to be pushed back behind it. So once we push 1 on there, we'll view the head, and we can see the first node is 23. Now when I push the second node, 556. So that is now the first one, and the next one within the list is 23. So that's just how this one works. And then if we pushed again, we have that one, then that one, and then that one. Now you can see with the linked lists, when you're trying to view it in a debugger normally, these kind of get a little annoying, right? You have to keep opening up the next pointer, looking at what's inside it, then opening up the next one, looking what's inside it, right? You have to keep like going down this tree of nodes, and that's not extremely helpful a lot of the times. So what Remedy does, it actually gives you a way to view this in an array sort of format. So let me show you what we're talking about here. All right, so if we're gonna go back real quick, just so we can make this easier to see, I'm gonna go to this list. We're just gonna put the value here instead, no big deal. We'll compile it. All right, so if I go back, and we're gonna now specify the list. And for this, we're gonna specify the head. So that's the first element that we're gonna be looking at in this list. And then we're gonna view each next pointer, and we're going to view 3 of them. Okay, so we'll hit that. So what this does is as we step through, okay, so we have our values that are populated, and we're going to push the first element onto the list. Now what you can see is right now how it should, when using this syntax, we can see we have the first element, it's at index 0. We push again, now we have 2 elements, right? And we can view it in this sort of array-like structure like we would with this. So it's not like these tree of nodes that you have to sift through. So this is actually really nice, and we can see our values right here. So right, so we have the first value, which is, again, this pushes, as we push, we're pushing the first one onto the head, and then the next one gets pushed down. So we can see our 3 values right here, and we can see them all in a line. So that is really nice. It's a nice way to view lists within Remedy. And again, this is one of the newer features that was just released. The version that we're using, again, is the 3.9.4. All right, so the next thing we're going to do is strings. So I'm just going to show you just some quick string views. Nothing too fancy here. So basically, if we have a simple string, oh, goodness, my typing today. All right. All right, so if we have a string, okay, go there, have a string, we'll view it in Remedy. We can see it's displaying it all here. Now, if that string was a little bit longer, blah, 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 right? It's the long string. Come back. You can see how it cuts it off here. So Remedy has a solution for that. So if you want to make sure you're viewing the whole string, we can specify with a format specifier, str, and you can see how it opens up this box to now view basically the entire string contents. So this is just an easy way to, if you have a long string, you can just view it all within the box here. You can also do a quick specifier account here, so you can display the number of characters you want. So if we did, actually there's no comma, right? So string 10, it's gonna just display the 10 characters or 20 or however many you want. And then I don't know if I mentioned this before, you don't have to use a number literal within these names in the watch window. You can use something here as well. So basically if something is in scope, you can use that variable as the count. So I used var here just because I had a variable already. Obviously this is a lot of characters that I would be displaying, but you can see how Remedy takes that into account and uses that variable, which is 3223, to display the string characters. So, that's always possible as well. All right, so the next thing we'll do is I'm going to look at a few more format specifiers that you can use, and we'll use our array as an example. So we already have it here, so I'm just going to run Remedy again. We have our array. We'll just put it in the watch window here, right? Add to watch, and we have our array that has 10 elements. Now, Remedy has multiple different format specifiers. I think in the notes here, it says that it's actually borrowed these format specifiers from WinDBG, which is another Windows debugger. It's a little more intense and thorough, but they grabbed some of these letters here from that debugger that you can also use in Remedy to view the memory in different ways. So if I wanted to, I can say specifically, okay, let's look at the byte values of the array, and we can also look at what the ASCII characters would be. So I can do something like db. So what that's saying is basically we're going to view the byte values. So you can see it's bundled it in these. So this is all hexadecimal. So 2 hexadecimal numbers equals 1 byte. So each byte is displayed here separately, right? So that might be easy for you if for some reason you want to view it that way, right? And then we can also view it as double word values. So that's going to be 16-bit, or I'm sorry, double word on a 64-bit machine is going to be 4 byte values. So if I do DC, we have 4 bytes, right? 1, 2, 3, 4, and then we have these 4-byte chunks that we can display our values in, right? And then again, we have with these specific specifiers, we have the ASCII characters that are displayed. Now, these particular specifiers are again notified within the notepad within the README of Remedy. So you can just go through and you can see what exactly they do. So you can see we did the DB, which just did the byte values and separated by bytes. This again separates by double word values with the ASCII characters. And you can see we can also use the DD. Now DD just removes the ASCII characters. So if you don't care about the ASCII, it's not representing ASCII, you can just remove it. Just use the DD specifier and you get the same thing with the 4 byte at a time values that you can then view. The other thing you can do with these specifiers is you can specify how many columns you actually want to look at a time. So you can see we have 4 columns right now. I think that's the default, but if you do /C and then you can say, let's just look at 2 columns, right? It'll now split it into 2 columns for you. And you can see that these byte addresses have adjusted as well. So we can actually look at it through these addresses 8 bytes at a time if we wanted to, because we can do, we can also do, instead of double word, we can do quad word. So basically on an x64 machine, this will be one whole 8 byte line. And then we can just say 1 column. And now we can view 8 bytes at a time pretty easily, right? This makes it a little simpler than trying to view it in a memory window where, we got this line here and we don't necessarily see the individual addresses between each 8 byte value on this. At least it's not very easy to make out. Whereas this way we can see each 8 byte line and then we can see the value that's in that line. So this can be useful for different things that you're trying to do with an array or something similar, right? So again, we have different other specifiers we can use. So we could even say like binary values. So we can display things in binary if we wanted to. And again, we can look at the columns. Now, since it's binary, we're just doing 1 byte at a time. So we got the 80, 81, 82, 83, and we're just viewing the byte values there. So we can also do, instead of just displaying all of these 4 byte values and displaying it all within the row here. So you see how it can go down all the way. It's going to display all 10 because we have 10 elements in the array. Let's say we only wanted to view 3 of them or something like that. We can also specify N3, and then we'll just get 3 values that we can view instead of all 10. So again, this can be helpful if you have a giant list of elements in an array and you just want to view some portion of that. You can just, view however many you want by specifying the number. And again, you can also, since we can just, this is just an expression parser here, we can just say, if we wanted to look at the array plus however many, maybe we don't want to look at the beginning of the array or somewhere in the middle, we could do like a +1. And then basically we're looking at the next address as the start. So the DF is actually looking at the 223 and then down. So, you can do little things like that as well to again, look at more in the middle of the array or somewhere else in the array that's not right at the start. And you can just specify how the amount you want to look at and that kind of thing. So this is pretty useful, and I use this a lot now, and it's really helpful with the programming workflow in my opinion. All right, so the next thing we'll look at is the matrix format specifier. So this can be used, so if you have a matrix, which is just going to hold a bunch of numbers here, and this is one way to do a matrix, right, where you have a union and then you can view it either as a struct, so you can do like the dot access, say I had a mate4 and it was some matrix, and we could then later use that as dot xx and assign that to a certain number, dot xy. That might be useful in some situations, or we could specify it as an array element. We can just say, okay, I want to look at this part of the struct as an array format, and then it can assign it that way, right? So that's just what this is doing. But you can see that with matrices in textbooks and in general math equations, you would see it kind of in this format, right? You would have a sort of block structure that you could look at the values in rows, and it just makes it more intuitive if you're able to view it that way. So if we go down here and I just create a matrix, so we just say make for a matrix, right? And then we just specify the identity matrix, right? Yeah, all right. All right, so we have a matrix here. Okay, can we do constant? Oh, there we go. And I don't know, do I need to do this? Whatever. Okay, so we have a matrix. So let's say we go to Remedy and we go and try and view that matrix here. You know, normal view would be something like this. So you would have the matrix and you can see everything's just kind of displayed in a row, or I'm sorry, in a straight column, right? Like just like an array would be. And that's not particularly helpful for matrices. You know, like I said, you typically want to view it in a sort of square pattern. So with Remedy, you can do that. So we can, again, use a format specifier with something that is a matrix that we want to view. We would type MTX, hit enter. Okay, not MTX. Oh, I think I have to do, because I have, yeah. Sorry, since I have this elements array. Okay, so you can take the matrix, and since we had it specified with float with these elements like that, we just have to access that elements first and then tell Remedy that's what you want to view as the matrix type. And then you can see now our values are displayed in kind of the normal matrix form that you're used to. So this is pretty cool, right? If you want to do a lot of math operations and have a lot of matrices you're working with, you can kind of view it and reason about it the same way you would in a math textbook. You can also take it and you can say you didn't want to look at it for whatever reason as a 4x4 matrix. Maybe you just wanted to look at it as a 2x2. You would just do something like that. And then you can now view it as a 2x2 matrix, right? So this is pretty cool. And like I said, it can be pretty useful depending on the context you're working in. All right, now the next thing we're gonna look at, this is kind of one of my favorite things actually, is a table format specifier that you can use within Remedy. So we are going to use a different structure for this. Okay, so what we're gonna do, so we have this rect struct, right? It just holds the positions of a rectangle if we were to have a rectangle in our program. Okay, sorry, I just created an array here of just 3 rectangles, so I just did it all in line here. So we have 3 rectangles that's within this array. So we'll go ahead and build, and we'll check this out in Remedy. All right, so we have our array. Okay, we'll view in the window. All right, now we have our values. Now, what you can do, and this is a little bit more involved as far as the syntax is concerned. I mean, once you get the hang of it, it's not a big deal. But so in order to display this, so you can see right now, since this is an array, we're just displaying it 0, 1, 2 down this column here. So what might be more useful is to view this as a table. It'll be a named table with named columns. So let me show you what that would look like. So we can specify a count. So since this is a 3-element array, we can say 3. So you want to do 3 elements in this table that we want to view. I believe you can omit this. You don't have to put it, but we'll just put that here for now. And then you're going to specify the parameters for the table. So you're going to start with a brackets, and then what you would do, in order to name a column, you're going to put the @ symbol, and we can say something like index. So this is going to display the index of the table. And then Remedy has a built-in variable that you use to grab the index out of the array. So you can just put index. Remedy will resolve that. So it's going to resolve the index as 0 down, right? We can then display the next column name that we want to use, that we want this to represent. So we could say something like width. So with this column, we want to display the width of the rectangle. Now, in our rect, we have a width field. So in order to grab that field out and display it, what we use is the $, and that's just going to tell Remedy Okay, we're going to grab one of the elements within that array. We're going to access the width field of that array. And that's it, right? We'll display the width. And then we can also do the same thing with height, and then $height. Okay. All right, so once we hit enter, we can see now what this does. It gives us a table view, and now we can view the index easily, we can view the width more easily, and the height more easily. So if for some reason this is what we were interested in, we have a much better way of looking at this and reasoning about kind of what's going on with this array and the rectangles inside it. Now again, this is pretty cool, and you can do different things with it. So let's say that we wanted to see where the right side of the rectangle is, what the point is, the point position of the right side of the rectangle. So we could just do something like, okay, we'll take the X position of each rectangle, we'll add it to the Y, so to the W, so the width. So we're going to take, if for example this 100, add the width of 300, and then we get the point that we're out at in space, saying we're on some sort of grid, right? Basically, I'm just showing you that you can do little expressions like this to then show information if you want. So we can just say X max position, hit enter, and now that has evaluated here, and now it displays within this table. So again, this will give us the max point of each rectangle, right? So you could do things like that within here. And again, you can see it's a little weird at first, but once you get the hang of it, you understand that these @ symbols, these are the names of the columns. And then the underscore index, again, is something that Remedy recognizes. So you just use that, and that knows that it just displays the index values 0, 1, 2 in the array. Now, again, you can, just like you would in C code, if you wanted to view further down the array, you can do an add there, and you can also do an add here. Now this will view from 1 down, right? Now we have the first index, which is now, since we added 1, is this rectangle forward, right? So we have, and I don't know, why is it 233? That's probably just garbage, I'm assuming. But anyway, so this is now just looking at the second element in the array and then down, because we did this +1. So you can do things like that as well, and you can see how we can view different elements if we want to, and that's all really cool. And like I said, it makes things a little easier for you as a developer to kind of see what's going on with your structures. All right, what else we have here? So looking at the help file, we can do disassembly format specifier. So we can just take an address and just specify the number of bytes we want to view, and we tell Remedy that we want to view this many bytes from this address, and please display that and disassemble that and display that. So what we could do is say, so from this part in our program, so let's say we put a breakpoint, come down. So the variable is basically near the top of our program here. We give the address to that variable, so that'll be the first address that we want to look at. We type in disasm, and then the number of bytes we want to view, so let's just say 100. Nope, did I spell it wrong? Yes, I did. Disasm. Okay, so you can see now it starts at this address in our call stack. It goes down, and now it will tell us kind of this whole program, the instructions that have been inserted for the assembly instructions for this program to run, right? So you can just view the disassembly really quick and easy by doing something like this, right? So that can be useful depending on the context you're working in. So just wanted to show that real quick. You can also just display, so Remedy has some built-in variables. Again, you can look at the thread ID of the current thread you're on when you're running. So if you have that money symbol, TID, so that's the ID of a thread. So you can see we're currently on the 17140 on this Windows system for a thread ID. You can also look at something like the program ID if you wanted to, right? So there's those different things you can use with that $ symbol. I believe I already showed the locals variable. Maybe I didn't. So again, this is something else that's built into Remedy along with the params. Okay, so it's underscore params or underscore locals, and these can be viewed. So the locals is just going to hold all the local variables that were within the scope. So we have all the variables here. So that's just a quick way to pull up all local variables. And same thing with the parameters. So the parameters that we are of the current function we're in are going to be displayed within this variable. So those are quick ways to access that. And other than that, I think we're done with the specifiers and the different variables used by Remedy. And now we'll go into just some of the things you can do with breakpoints. Okay, so with breakpoints, you have some of the familiar things that if you're programmed for any length of time, you've probably already used. So you have, let's take an example here. Let's say we have a breakpoint that's set at this variable. We can, in Remedy, if we wanted to edit this breakpoint and say we only wanted this to break on a certain condition. So actually for this to work, we'd have to do it here. So variable is set to 3223. So let's say we only wanted this breakpoint to break whenever that variable is 3223. In the condition, we can put that variable's name. So Remedy is going to resolve anything that's within scope. So we can use the name that we have in our current function, and we can use that as the condition. And we can say if var equals 3223. Okay. If it does, then it'll break. So if I hit F5, you can see it's going to break there. Now let's say I stopped this, went back to my program, and we said instead I want it to be 100. Then we go back, and we run it. Nothing happens, right? Because we don't stop on that breakpoint. It just goes through our program and ends. So I would go back, 3223. And now it stops on it because I changed it back to 3223. So Remedy, when you do things that way, will keep that breakpoint with that condition, right? So it has that condition in there. So even across runs, it's gonna hold true. Okay, so that's one of the things you can do. The other thing is just a function breakpoint. So you can set a breakpoint on it when a specific function is hit. So in order to do that, we'll just do it. We'll go to so it's not running right now. We can just go to the breakpoints window, say new function breakpoint, and we'll just add the function name. We'll say add func. We won't have a condition here for now. We'll just say, just add it. Whenever add func is called, go ahead and break. So now if we hit and run, you can see it broke on the add func function. All right, so that's simple enough, right? All right, so the next thing we'll look at real quick here is the processor breakpoint. From my understanding, basically debuggers have the options to tell the CPU on a certain architecture. So in this case, the x64, we can say whenever you're writing to this address, whenever you see that, please notify us so we can break the program at this point. So if we were to set a breakpoint here, let's say, and on that breakpoint, actually, so one other thing about the processor breakpoints is you'll notice if I go to try and add one when I'm not running Remedy, I cannot, right? It's grayed out. I can't select that option. So I have to first step into my program. And now, I don't know why it's saying that, just var, whatever. Okay, so we're in the program, and now I can left click and select new processor breakpoint. So this is because, whenever the Remedy doesn't know what the address of anything is going to be until your program is run. So once we run it, we can now specify that we're going to have a variable var, and I want you to look at the address of that. And so it's an int variable, so it's 4 bytes. So it's just going to say the number of bytes we're looking at is the 4 bytes of that variable. And if any of those 4 bytes are written to, we want you to break, right? So if we hit OK, we now have a processor breakpoint set. So you can see I'm on printf. If I hit F5, it now breaks here. So it's going to break one line after, because obviously this variable doesn't get set until after it's run. So it's run, it's set, and then the program stops. So that's what the processor breakpoint is saying. It's just saying again, we specified whenever those 4 bytes are written to, which they were here, any of those 4 bytes we want you to break. So again, you can do this with read and write. So just reading from the variable will also break the program, and anytime that variable has been executed or something has been executed, you can also break the program. All right, so that's a processor breakpoint. Okay, so one of the last things we'll look at here is auto-enabling breakpoints. This feature is actually just added, I think, in 3.93. So what it allows you to do is have, if you have multiple breakpoints, you can actually take a couple of those breakpoints or whatever breakpoints you want and child or add them to a parent breakpoint, and then they will only enable if that parent breakpoint is hit. So in order to make this a little more concrete, I'm going to just create a quick sample within our file here, and we'll go through that. Give me one sec though. Okay, so real quick, I just added a quick test process here that's just going to show us this feature I've been talking about. You'll notice I just have a simple function here called process, and that's going to get called within this loop. Now, let's just say we do this the traditional way, and we go to our debugger, and let's just say we, for whatever reason, want to break on this line within the function. But let's say we only wanted to break in this line every so often, or if certain conditions are met. This will not happen currently, right? Because in this loop, process gets run every time. So if I hit F5, we hit the process function, we come out. F5, process, come out. F5, process, come out, right? Because we have 10 loops that we're going through. So that means that breakpoint is going to get hit every time. So the difference that I was going to say, so let's say we only wanted to run into this function, run into that breakpoint whenever we have a special trigger, some random thing that gets triggered within our debugger. So in this case, I put the variable special trigger. You know, this is just some arbitrary thing we're just putting in place of anything more complex right now. So we're going to say whenever the special trigger is actually hit, whenever this breakpoint gets hit, then we want to enable this one. So in order to do that, let me just remove both breakpoints so that I know which one's which. So we'll set this one. So this will be our parent breakpoint. And then we'll set this one. So again, we only want this breakpoint to run whenever the special trigger gets hit. And basically that only happens when I equals 3. So we're going to take the breakpoint here, which is this one, Control Shift, click, and we're going to, you see we just made it a child of the special trigger breakpoint. So what this will do is if I run, we actually got a break here at the special trigger, which means I is 3. And you'll see that also enabled this breakpoint now. So if I is 3, that means that this function was run a couple times already before this got hit. So this breakpoint was never hit. Right now we just hit this breakpoint here for special trigger. So if I do hit F5 now, it will now break on this breakpoint. So again, that can be pretty useful for certain situations. And you'll know it kind of when you come across a situation that this might be useful for. So like I said, this is just a quick example to show you kind of how it works. But again, that is something that's nice to have, because like I said, we don't always want maybe our breakpoints to run through an entire for loop for every part of the loop or whatever, or we only want them to run whenever a certain condition has been met. So we can do that now with Remedy with these parenting and child breakpoints. All right, so that's basically it. There's a couple other things that might be in the help sheet here that you might want to look at. I didn't quite go over everything, but I gave you a pretty good overview, and I think from this point forward, you should be able to figure out anything else you want to look at. As new versions come out, you should be able to look at the help file here, see any additions, and then go from there. All right, so that's about all I wanted to show you guys today. So again, this is RemedyBG, developed by a single developer, and he actually has a Discord channel. So if you wanted to ask questions and that kind of thing and have a community help you, if you go to Discord, it's actually within the Handmade Network Discord channel, and then it's just a project located. So it's under projects, and there's the thread for RemedyBG. So the guy's name is well, the username is X13Pixels. I actually forget his real name, so sorry for that. But he's a really nice guy, and he answers basically any question you have here. And if not, we also have community members that will help you out as well. So I hope you learned something today, and have a good one.